Welcome to Orca Security. If we consider what we've done from a security perspective in the past, it's not a long list. First, agents. Agents are installed and maintained as another application that run alongside your important workloads. Agents provide visibility into what's running, rogue activity on the host, and they detect data that shouldn't exist. The problem with agents, as I'm sure you can appreciate, is that you must install and maintain them. Another approach that's been used in the past has been the network scan. Network scanners probe resources externally, looking for known configuration errors. And these two solutions have really been the cornerstone of data center and cloud security for years. However, we saw two main problems to this approach. The first is that agent deployments do not scale. On average, we've seen that less than 50% of all cloud assets covered by all of the security solutions that an organization leverages, including agents. It's almost impossible to deploy agents universally everywhere. The second problem is that there are simply too many security alerts. We found on average that you'll discover 10,000 vulnerabilities for every 100 assets. The main reason for this is that these tools work in their own respective silos and they don't understand the overall picture and how cloud security controls relate to one another. The agent-based approach sends all the alerts to the security team and puts the onus of responsibility on them to manually add context. So to address these shortcomings, Orca was founded on a patent-pending technology called side scanning that has several industry-unique benefits. First, the Orca approach provides complete coverage. Your entire cloud estate is covered within minutes. Second, it provides superior security, much better than we had in the local data center. And I know that's a big claim, so let's dive deeper away from the what and into the how. Orca does not require or depend on agents, network scanners, or cloud security posture managers, and yet we're able to detect risks within workloads without code running, without literally sending a single packet over the network or running any ops code in your environment. Instead of contributing to the problem and interfering with the cloud environment, we collect data directly from the workload's runtime block storage. This is in fact the first sort of secret sauce of the Orca approach. We combine this intelligence with cloud metadata, data like which security groups cover which workloads, how traffic is routed in your virtual networks, and much more. And instead of integrating with each and every workload requiring credentials, network access, and the installation of agents, we read from the common shared virtualization environment. And this facilitates an immediate understanding of all the major risks in the cloud estate. So in the end, you're achieving much more comprehensive visibility because you don't require per asset integration like agents do. The Orca approach is complete. We detect everything that exists now, but also into the future. No more orphaned workloads because a business unit decided they didn't want to fuss with security agents. Side scanning is also 100% zero impact. Orca has no effect on the workload as there's no code running or installed. We have Fortune 500 organizations as customers that have onboarded their entire cloud estate in less than a week. There's simply no other approach to this problem that can make that claim. Good, so now that we have a conceptual understanding of side scanning and the advantages it provides, let's review the second pillar of Orca, if you will, context. We talked about how Orca understands data on the host via the very powerful side scanning approach, but that process also analyzes the host configuration, whether that host is a traditional instance or a containerized workload, and understands which services are running, what the firewall configuration looks like, how applications are configured, and much more. At the same time, Orca is reading metadata in a read-only fashion from your cloud provider via API that's focused on the configuration of everything that's slightly above your workload. Concepts like security groups, VPC configuration, identity, access roles, and policies. Orca combines all of this information into a context map. Orca builds this context map by mashing up all the deep workload discovery detail combined with cloud context. Orca will discover cloud assets, and in fact, Orca exposes this detail in the asset interface of the service. Orca identifies asset roles, which resources are configured to do what and the permissions they have. Orca then identifies connectivity, which networks are public-facing versus those that aren't, which VPCs have internet gateways configured, for example, and much more. And then, and only then, Orca identifies risks with full contextual awareness. So in the end, we believe context is mandatory for any security strategy. Over thousands and thousands of alerts, which are those that if not addressed will likely lead to compromise? Which require action now versus those that are informational? Context is your answer. First, you get better and more effective prioritization. Orca takes into account the surroundings of workloads to determine what's critical. Next, because Orca has full visibility into your whole cloud estate, we compare resources that should look the same but don't, like cluster members. A difference like this can be indicative of compromise and will be missed by other approaches without context. And then lastly, misplaced data or configuration. When Orca finds keys in a workload, for example, secure shell keys, cloud keys, or others, because we understand the full context of your cloud efforts, we can map those keys to your environment and show you exactly what they provide access to. Context absolutely matters, and we believe it's the very best way to increase the fidelity of your alerts and ultimately address what's important to keep you safe. With that, let's take a look at the product. Getting started with Orca is super simple. If you're an AWS, Azure, or GCP customer, you're basically doing the same thing. On AWS, we're creating a service role and a policy. Once that's created, we're bringing back the Amazon resource name and pasting it into the box here. And once you're done, it's really a one and done installation. No need to do anything else. From that point on, Orca will understand everything that you debut in your cloud estate. And really, once Orca is installed, it begins the process of side scanning and understanding the context of all of your workloads. And very shortly, you will see the top 5 risks across each of the malware, vulnerabilities, neglected assets, outdated resource, data at risk, insecure configuration, lateral movement, authentication categories. Which is great for the top 5 risks, but most of the consumption alerts will be done within the alert interface. And if we take a look at example, we'll take a look at straightforward vulnerabilities, and we'll drill down a little bit further into web service unpatched. And let's take an example of context. So if we take a look at these two alerts right here, they look very similar. Web service unpatched of Nginx and web service unpatched of Apache. But you'll notice they have 2 different kind of risk profiles. One is risked as imminent compromised, and one is risked as simply hazardous. You might ask yourself, why? The difference is that one of these has to do with a workload that is internet facing, and one of these doesn't, right? And that calculation of internet facing is made in a number of ways. It's not a simple, dumb IP address check. It's a check all the way from how the workload is configured to serve that information, up into the security groups surrounding it, the route tables, the existence of internet gateways, and even more. And so in fact, the second alert you're seeing actually isn't for a workload at all. It is for a container image, right, in a container repository. And so that's why you get the hazardous, right, that there is a risk here, but until we understand that it's public facing, right, it doesn't have that sort of highest risk profile. Orca also exposes all that information obtained from the side scanning process and more into a nice inventory. And you'll see, for example, if we take a look at container images, we'll find that very same image we just saw. And in fact, if we investigate that as a resource instead of one particular alert, we'll see that indeed it does have that web service unpatched alert, and then a bunch of other informational alerts around software vulnerabilities as well. And in fact, this web service unpatched alert rolls up many different vulnerabilities into one single alert, and you'll find that theme consistent through Orca, right? If I update this version of Apache, I will take care of all of these different CVE findings, which is very different than platforms that alert you discreetly, right? Only incorporating the CVSS score of each vulnerability. Orca certainly takes them into consideration, but understands a number of additional environmental sort of contextual factors that help in understanding what's important, what can be fixed right now versus, what can wait. And then lastly, Orca has a very, very simple instant on compliance, both at the workload level and at that cloud control plane level. So I can be looking down at my workload level measurements, or I can be looking at measurements more at that cloud control plane level like this. I know that's absolutely a crash course on Orca, but I hope that provides some value and helps you understand how different Orca is in its approach to both workload and cloud control plane security.